Let's see now very quickly another example where we might have something like this. So in this example right here, we have 2 terms in the first pair of brackets and 3 terms in the second pair of brackets. So in these cases, we will use a very similar method, really same as before. I will use 2 colors for this. So let me use blue for the arrows, the lines coming out of x. So here we've got x will be multiplied with all of these 3 terms in the second pair of brackets. And I will use red for the lines coming out of 3. So 3 will be multiplied with all of these 3 terms as well. So if we start with x times x squared, so x times x squared, well, that gives us x cubed, because x times x times x is just x cubed. Then we move on to the next term, which is going to be x times 2x. And well, firstly, that's going to be 2 times something, because x times 2x, well, you can think of it this way. It's like saying this is 1x. So 1x times 2x, the 1 times the 2 will give you 2. And then the x times x will give you x squared, because it's x times x. So when you have it 2 times, the power is 2. And then finally, you'll have plus. Now, x times 4 is the same as 4x. So we tend to put the 4 in front. And that's it with the blue lines. Let's move on to the red ones. So here we will have, firstly, plus 3, positive 3 times x squared. So that gives us plus 3x squared. That's simple. Now, moving on to the next one, we'll have plus 3 times plus 2x. Well, 3 times 2 gives us 6. So 3 times 2x gives us 6x. And then finally, we have plus 3 times plus 4, which is the same as plus 12. And we are now ready to just collect like terms here. So what I'll do now is I'll use black ink to circle all the like terms. So notice here we've got plus 2x squared, and then later on we have plus 3x squared. Well, that is actually 2 lots of x squared plus 3 lots of x squared. So that will give us 5 lots of x squared. And then let me use rectangles for the other terms. So here we have plus 4 lots of x plus 6 lots of x. Well, that's 4 lots of x plus 6 lots of x, which gives us plus 10 lots of x. And let's not forget to copy that x cubed in the beginning. And at the end, we will also have a plus 12. So this one was slightly more complicated, but we got there in the end. The process was quite similar to what we've seen before. This is pretty much it when it comes to the theory, guys. I just wanted to mention that in some cases one might get something which looks a bit more tricky, but actually it's not that tricky. If you have x plus 2 cubed, for example, which looks like a tricky thing, we will have to rewrite this as x plus 2 times x plus 2 times x plus 2, and then it will just make our lives a bit easier. The textbook has chosen this approach. Instead of saying it's x plus 2 times x plus 2 times x plus 2, because that's something cubed, that's what it means to have something cubed, they've chosen to do it this way. Instead of saying x plus 2 times x plus 2 times x plus 2, they said, well, this x plus 2 times x plus 2 is actually x plus 2 squared. And this will save us a little bit of time, because in the previous lesson, we saw how to expand things like this. We saw this formula, which was a plus b squared, which gives us a squared plus 2ab plus b squared. So this is what the textbook has recommended here as a solution, and it makes sense. It's actually a good shortcut. So they've said, well, that means that the second pair of brackets will be x squared plus 2 times x plus times 2 plus 2 squared. So that is using this formula from that I just underlined. And then basically, if you have x plus 2 times this term right here, we can simplify this. You'll have x squared plus 4x plus, and then that 2 squared becomes 4. And then you can follow the example I introduced previously, where you just multiply the x with all the different terms inside the second pair of brackets. You multiply all the terms by 2, and then you collect like terms. So I don't want to bore you with the details, but basically these steps are also found in the part from the textbook, which I've uploaded. So this is pretty much the idea. I'm going to let you experiment with this, do a bit of practice on your own, guys, because I do think that practice is what we need here to make sure that we become more confident with these this topic.